Good morning all. Myself Lakshmipriya from Department of CSE. I am working as an assistant professor in SA Engineering College. Today I am going to discuss a functional dependency in DBMS. Let's get into the topic. Before going to functional dependency, I would like to tell about some information about DBMS. DBMS means database management system, which is used to storing the data and maintaining the data. If the user need any information about themselves, we can retrieve the data from database. There is a number of issues. So to reduce it, we need a functional dependency. First, what is mean by functional dependency? Functional dependency is the relationship between attributes of a table. So, for example, if there is a student table, there is a n number of attributes like register number, student name, age, mark, like that. So, there is a relationship between each attributes. So, next one is a functional dependency helps to maintain the quality of data in the database. Here the quality means database should maintain some quality of data, accuracy, integrity, consistency and durability. Next one is the normalization. Normalization are based on the functional dependency. Normalization is the process of organizing data in the database, which is used to reduce the redundancy data and improve the quality of the data. For normalization, we need a super keys and a candidate keys. So here we need a super key and candidate key to reduce redundancy in the database. For this, we need to find the functional dependency. Redundancy means eliminating same data in multiple tables. For example, in a student database, there is a n number of attributes called register number, student name, then age. So this age will be present in n number of tables. To reduce this age, we are using functional dependency. Next one is the integrity. This integrity which is used for the data accuracy. A functional dependency is denoted by an arrow called arrow mark. Functional dependency is denoted by arrow mark. Functional dependency of A on B is represented by A determines B. This arrow mark is called as determines. This arrow mark is called as determines, where A is a determinant set and B is a depending attribute. So here A is a determinant and B is a depending attribute. For example, register number determines name. So register number is a determinant attribute, name is a depending attribute. It means with the help of register number, we can find the name of the student. Here in this example, vehicle ID determines name, model and make, which means here vehicle ID is the determinant attribute, name, model and make is the depending attribute. With the help of vehicle ID, we can determine the name of the vehicle, model of the vehicle, then making of the vehicle. Next one is a property of functional dependency. So there is some properties in functional dependencies: reflexivity, augmentation, then transitivity. First, I would like to say what is mean by reflexivity. Reflexivity states that if y is a subset of x, then x determines y. Next one is the augmentation. It states that if X determines Y, then X is Z determines Y is Z. Last one is the transitivity. It states that if X determines Y and Y determines Z, then X determines Z. For this, for example, employee ID, comma, name is a one type of determinant which determines name and address of the employee. Here we can write it like a employee address. So this is the transitivity. With the help of employee, we can find the address of the employee. Next one is the types of functional dependency. There is a 4 types of functional dependency. One is a trivial functional dependency, non-trivial functional dependency, multi-valued dependency. First one is a trivial functional dependency. It means X determines Y is called a trivial functional dependency if Y is the subset of X. Here there is an example. Here we have to consider the employee table. In this there is a attributes called employee ID and name. So employee ID and names are called determinant attribute. Name is a determine attribute. So with the help of employee ID, we can find the name of the employee. Next one is a non-trivial functional dependency. X determines Y is called a non-trivial functional dependency if Y is not the subset of X. In this example, employee ID is a determinant. This is the determine attribute. So name is not present in a determinant attribute. So it is called as a non-trivial functional dependency. Next one is a multi-valued functional dependency. It states that X determines Y is Z. There is no functional dependency between Y and Z. So here there is an example. Employee ID determines name and age. There is no any relationship between name and age. So it is called a multi-valued functional dependency. Next one is a transitive functional dependency. It states that X determines Y and Y determines Z. Here dependent is indirectly dependent on determinant. Here this X is indirectly depend on Z. It states that, for example, employee ID determines department and department determines street number. So here employee ID indirectly defines street number. With the help of employee ID, we can find the street number of the employee. So here I am having some problems which is related to functional dependency. For normalization process, we need candidate key, and super key. These two keys are determined by functional dependency. So these two problems based on candidate key, super key. Okay. First problem is in a schema with attribute A, B, C, D and E, following set of functional dependencies are given. Here A determines B, A determines C, CD determines E, E determines A, then B determines D. In this example, A, B, C, D and E are the attributes in table. These are the attributes in table. These are all the functional dependencies. Functional dependency on table. So the question is, which of the following functional dependency is not implied by the above state? So in this, which one is not implied by the above state, we have to prove it. The solution is here. There is a solution. For this, we need to find the closure for the CD determines AC. We need to find the closure for CD determines AC, then BD determines CD, BC determines CD, then AC determines BC. So first we have to find the closure of CD. We have to write the subset of CD value. So C and D are the subsets. It follows the transitivity function. Then we have to consider these dependencies. Here CD determines E value, so we have to write in the subset. Then E determines A, so we have to write that A value in the subset. Then A determines B value, so we have to write B value in the subset. So in the subset, the 5 attributes are present. So it is determined by this functional dependency, which means CD determines A is derived by this functional dependency. For like this, we have to find closure for every determinant. Next example is BD determines CD. So here we have to find BD closure. So B and D we have to write in the subset. Then we have to check, is there any functional dependency in the given question. Already B determines D, so there is no any determinant, so the value is B comma D. Here the rest of the values are missing. A is not present, then C is not present, E is not present. So BD determines CD is not implied by this functional dependency. Next one is, we have to find the closure for BD determine CD. So here I am going to find BC closure. First I have to write the subset of BC. B comma C, it will be present in this subset. Then B determines D. So we have to write the D value in the subset. Next, CD determines E. So we have to write E value in the subset. Then we have to write A value because E determines A value. So here I am having A, B, C, D and E value. It will be present in this functional dependency. So B determines C will be determined by this functional dependency. Next one is AC determines BC. For this also I am going to find the closure of AC value. AC closure, A comma C are the subset of AC closure. Then A determines B, so I have to write the B value here. Then B determines D, so I have to write the D value here. C and D determines E, so I am writing E value here. So here I am having A, B, C, D, E. These attributes will be presented in this functional dependency. So this is also implied by this functional dependency. Okay, so my conclusion is BD cannot derive CD, hence not implied. The answer is BD determines CD is not implied by the above dependency. There is a question called how to find the candidate keys of given relation. Consider a relation or A, B, C, D, E with the following functional dependency. A determines B, D determines E. Here we have to find the number of candidate keys of R. So in this functional dependency, we have to find the how many number of candidate keys in this dependency. Why we have to find the candidate key means for normalization process we have to know the how many number of candidate keys and the super keys which will be present in a table. For this reason we have to find the candidate keys with the help of functional dependency. Let's go to the solution. Again, this is A determines B and D determines C. These are given functional dependency. For this, we have to find the number of candidate keys available. First, I have to find closure of attributes in a given relationship. In a table, I am having A, B, C, D and E. These are all the attributes which will be present in my table. So the closure of A, B, C, D, E is itself. So we have to write A, B, C, D, E in its subset. So it is a super key. How we said it is a super key means the attributes which will be present in a relation table, it should be in a closure subset. So A, B, C, D is here. Relations also having A, B, C, D, E attribute. So these both are same. So this is called a super key. Next one is here A determines B, so I can remove this B because A can determines the B value. Next I have to find the A, C, D, E. For this I have to find the closure value. Again this A, C, D itself is A, C, D, E itself is a closure. Next one is here D determines E. A determines B, so I am writing B value in this subset. Here now we have to check in this ACD closure A, B, C, D, E is the subset values which is mapped to the relation attributes which will be present in the table. So it will be considered as a super key. Next one is we have to remove E value here because D determines E. With the help of E we can determine E value. So I am going to eliminate this one. Now I am going to find the closure of A, C, D. So as I am said before, A, C, D as a subset of ACD closure, then A determines B. So this A value determines B value. So I am writing B value here. Then D determines E. So I am writing E value here. Now I am going to compare this subset values with my relationship attribute. Both are same. So this is also one of the super key. Next I am going to find the closure of AC, AD, CD and A. So these are all not super keys because there is no attributes which will be present in this relation attribute. AC, AD, CD and A are not a super key. So in this here I am having three super keys. A, B, C, D, E is a one super key. A, C, D, E is another super key. A, C, D is another super key. So the candidate key is identified by the minimal set of super key is considered as a candidate key. Underline the word minimal set of super key is considered as a candidate key. So in these three, which one is having minimal set means ACD is having minimal set of keys. So this ACD is considered as a candidate key. So for this problem, the answer is one. Because there is a one candidate key, there is only one candidate key, ACD. Thank you all.